My name is Jen WEDDLE, and I am one of the co-directors of Okanogan Highlands Alliance, as Kayla mentioned. And I am here to share information about the strategies we've used at our Triple Creek wetland restoration project in Chesaw, Washington to reduce.
Hey, Jen, I'm just going to interrupt really quick. Hey, Kayla, could you click on display settings and then switch the screens right at the top, display settings? Do you see it on your screen?
Oh yeah, if you can just do the.
You see it at the top left, just display settings. It has a drop down menu.
I'm gonna mute myself from.
Do you see it?
I don't.
At the top. There's show taskbar, display settings, and slideshow. The very, very top.
Oh, yeah.
And then just swap presenter. There you go. Perfect.
Thanks.
There we go. Thank you.
Jen, you're muted now.
Okay, thank you. Okay, so I'm here to share information about the strategies that we have used at our Triple Creek wetland restoration project in Chesaw, Washington, to reduce reed canary grass and give native riparian plants a chance to get a foothold and establish and ultimately outcompete the weeds. So I'll be sharing strategies and lessons learned over the 6 years of our project. Okay, next slide, please. So just to get you oriented, here we are in the northeast corner of Okanogan County, approximately 2 miles from the Canadian border in Myers Creek on the ancestral homeland of the Lakes people. And Myers Creek is a tributary of the Kettle River, which meanders back and forth along the border before joining the Columbia River in Lake Roosevelt at Kettle Falls. Okay, next slide, thank you. And to give a little bit more context, zooming in, here's our treatment reach within Myers Creek, which is just under a half a mile in length. And this reach is known locally as Triple Creek because this wetland complex is at the confluence of 2 intermittent tributaries, Bolster and Thorpe Creek, along with Myers Creek. Okay, next slide. So you might be asking what happened in Myers Creek that necessitated restoration. Well, going back to 1997, we see that Myers Creek is a low gradient channel with a well-connected floodplain. But in 1998, the channel incised rapidly during a large flood event. Next slide, thanks. Down to a new base elevation where it remained until our project started in 2016. So the incision trench was about 10 to 12 feet deep in places. The wetland drained and the riparian plant community was taken over by our dear reed canary grass, as well as Canada thistle. And OHA's restoration project began in 2016 and was supported by Department of Ecology Section 319 funds, as well as land stewards who are interested in restoring the wetland, as well as numerous partnering organizations and individuals. OHA has led the effort to grade the stream bed and increase the sinuosity of Myers Creek using Beaver Dam Analogues, as well as aggressive manual weed treatment, riparian planting, and long-term plant care. So here we are in 2021. Over the last 5 years, OHA and our partners have installed and managed 43 BDAs and planted 13 planting plots, as well as many individual plants on the stream banks, and more recently in the stream, like in the Beaver Dam Analogues as they accumulate sediment, as well as on inset floodplains as the stream bed degrades. And we have also used mowing to control weeds along the paths and along the stream edge around our plantings. So Triple Creek offers an example of process-based restoration, where we're working to restore the physical processes in order to improve the biological processes, increasing the health of the stream and wetland ecosystems. And all of our project elements are interconnected, from the in-stream construction and to the riparian planting and weed management, as well as monitoring and education. And so as far as the plant community is concerned, we're looking to create conditions that are less likely to favor the noxious weeds and more likely to favor a healthy, diverse native plant communities. So this picture kind of shows an overview of what our project looks like recently. Some of the planting plots visible. Okay, next slide. So with this concept of process-based restoration in mind, our overall project goal is to improve ecological function and complexity within the Triple Creek Reach by recharging the floodplain and restoring habitat for native fish and wildlife. But today I'm going to focus on objective number 4, our work to establish a riparian plant community by getting more water and more shade to the wetlands. Reed canary grass is a critical element in this story. Since the late 1990s, it and Canada thistle have outcompeted the native plants in our now dry and sunny floodplain. Okay, so developing a riparian plant community is a long-term strategy at Triple Creek. This overview slide shows the steps of the process we've engaged in, but in the interest of time, I'm going to focus on the bullet points in black. The ones in gray are really important, but will be pretty different for different project locations. So I was trying to focus on the aspects of the process that might offer some new and different ways of operating that could be put into practice in lots of places. So dealing with the reed canary grass is one of the steps in our process of reestablishing a riparian plant community, but it cannot be done in isolation. So we have found that reed canary grass is so persistent, and once it takes control, it takes a lot of persistence and adaptive management over the long term to keep it from dominating, like years. So next step, I know that there's been a lot of talk already today about determining goals, setting your goals. This is true for riparian plant communities and battling reed canary grass as well. So determining your goals can help to determine where to plant and what species. I noticed that in one of the poll questions that was submitted had to do with recommendations about planting along a creekside strip that's dominated by reed canary grass, which is actually a lot of what we're doing at our project. Our goals include increasing the sinuosity of the creek, as well as shading the creek and floodplain, as well as establishing a diverse community. And so planting in that strip meets several of our project goals. However, it's also worth saying that if you are working on a project where you anticipate your stream changing course quite a bit, you might consider planting a bit further back. We did lose a planting plot to the stream as it changed course. And it's quite a bit of effort to create a planting plot. So it might be wise to plant further back, at least at the start of a project. So in any case, our planting plots are primarily located in areas that are dominated by reed canary grass. Some are close to the stream bank and others are set back into the shade of established trees. And that's allowed us to take advantage of existing conditions and to plant a greater diversity of plants. We have 13 planting plots that exclude reed canary grass and allow the native plants to flourish within them. And although the reed canary grass encroaches from the outside and creeps into the plots, annual manual weeding helps to give the native plants a competitive edge. Okay, next slide. Okay, so this is an example of a spot at Triple Creek where we got a clue about how to move forward. So this photo shows stinging nettle growing among the reed canary grass that looks to be successfully competing with the reed canary grass. And this offers an example of the type of condition that we're working toward, where the shade from the trees allows native plants to compete with the reed canary grass, which is very sun dependent. Okay, next slide. All right, so once we determined our project goals and planting locations and a plan, we started on the ground site preparation. In all of our reed canary grass strategies, this one treatment was not enough. So after removing the reed canary grass, we mulch and plant to weed and mulch some more and weed some more. And this photo shows scraping with an excavator, which involves taking the biomass and the top of the soil from a planting plot. And we chose this method because there was a ditch or a trench that was draining the wetland nearby. And so we used the biomass and the sediment to plug that drain and hold water into the wetland. But this was actually the only time that we used this scraping strategy, because we didn't necessarily have a need for more fill at this site. So next slide. The strategy that we primarily used at Triple Creek is smothering that reed canary grass. And we use a plastic weed barrier to do this. The material we use is a pond liner, which is a 70 millimeter low density polyethylene, which was repurposed from the local gold mine. It's proven to be really UV stable, and we've used it for 6 years now. We kind of move it around from place to place, and it's holding up really well. The downside of this particular material is that it can be expensive and hard to find. And so many of our plots before we got this material were simply mowed and then mulch applied, kind of like Judith's presentation. The pieces of pond liner that we have are about 10 feet by 20 feet, and we use them to create plots that are between 200 and 400 square feet. Downside, of course, is that it's plastic and eventually it will wind up in the landfill. But we anticipate using this same material over and over again for many more years. Okay. Oh, I guess the other thing to mention is that we leave that weed barrier in place for about a year or more before we do anything else. So the individual plantings is the other way that we have worked with reed canary grass. We've planted many individual plants throughout the site, which involves removing the reed canary grass from a small area, but large enough to mow around fairly easily. So a lot of manual effort, but also can be great for volunteers. Okay, next slide. And then once our reed canary grass is smothered or removed, we add mulch layers. So we find local sources of plain brown cardboard, and then also lots and lots of hog fuel or bark for the materials. And one thing that we've learned is that you always need more than you think. Just last year in 2021, we put close to 13 tons, which was like 4 dump truck loads of hog fuel on about 15,000 square feet, which is about 0.3 acres. And we try to put at least 4 inches of mulch in planting plots and up to 12 to 18 inches around individual plants. Next slide. Our strategy for putting down the mulch layers is to overlap like 2 or 3 layers of that cardboard by about 6 inches, and then top that with at least 4 inches of that hog fuel for a total of between 6 inches and 18 inches of mulch atop the smothered reed canary grass and around the new plants. And the more mulch you put down, the easier the weeding will be. Okay, next slide. Okay, so species selection is something that I didn't want to focus on since it's so site dependent, but it seemed remiss to leave it out completely. So at Triple Creek, we've chosen species that will develop multiple canopy layers over time that will offer benefits to wildlife, particularly beaver, and are flexible to changing hydrology. So we try to source local plant stock since the genetically adapted native plants have evolved to succeed in this place. And lastly, we plant different forms of plants. So we will plant willow whips and cottonwood live stakes, as well as container plants. And we prioritize planting a diversity of species in order to fill a variety of niches and establish plants that have co-evolved relationships of increasing those mycorrhizal interactions and connecting plants with the native pollinators. So at Triple Creek, we have planted a lot of different species, but including willow, conifer trees, shrubs, and sedges. Okay, next slide. Okay, so once our mulch layers are down, we try to keep the layers intact. And a way that we have found to do this is to use rebar poles, which you just like slam them down through those mulch layers, and it punches a hole right through the bark and the cardboard and into the soil. And then when you can pull the rebar out and slide a willow stake in, which is what you can see some of these students doing in the foreground, and then pouring in some muddy slurry into the hole after the willow is in there to get the air out and ensure immediate contact between the stake and the soil. This is an awesome volunteer activity also. Okay, next slide. So then before leaving our new plants to fend for themselves, we put up cages or fences. Initially, plants and cages were smaller around our individual plants, but after about 3 years of growth, we needed to expand the fences to allow for more growth and to reduce the browse on the branches that we're poking through. So one of the lessons that we learned is that it is helpful to put the fence on top of the mulch rather than outside the perimeter of the mulch. That way it's easier to weed in the long term. Many of our planting plots have reed canary grass growing up into the fences, which is difficult to weed. Okay. And the last kind of like big point, thanks. The last kind of big point of my presentation is that the battle against reed canary grass is a long one, and we have committed to long-term efforts to weed, as well as your next slide, to irrigate. So an important consideration when you're thinking about irrigating is whether water rights are available to do this. You may need to truck in water. So new plants we found don't require a ton of water, but some water is helpful multiple times in the first few years. So we water on an as needed basis from year to year. In addition to the planting plots, we also mow quite a bit. Between May and August, we mow about 2 acres of paths and around the plantings approximately once a month. So this photo shows how shade plus mowing is successful to the point of looking almost like an herbicide has been sprayed in that shade in the middle. Mowing on its own does not necessarily reduce the vigor of the reed canary grass, but it shortens the grass and at least allows more sun to reach any small native plants that are trying to grow. And then if you pay attention, you can take care of them. And then lastly, every aspect of our project, I see Ryan's comment, highly labor intensive is true. So every aspect of the Triple Creek project is adaptive. So we prioritize monitoring throughout the growing season each year and anticipate caring for plants and continuing to manually control weeds for the long term. Already, many of our planting plots have grown up to be quite dense and require less maintenance, definitely less irrigation, but also less weeding inside some of the older plots. And always we expect the unexpected, so it'll be interesting to see what happens this year. And this picture and the next one shows how quickly plants grow and things change. So this was a drone image taken in June of 2018. And you can kind of see this brown planting plot. And then in the next slide from 2020, you can see that same planting plot all green. So things change very quickly. Okay, so to finish up, this whole presentation has basically been a tale of the lessons that we have learned through our 6 years. But here's a summary of some of the important points. I think a huge one is applying for the funding that you think you'll need to do things the way you think that they will work. And everything takes more time and mulch, also more mulch than you think that it will. And so, especially at the beginning of a project, anticipate more effort than you think. Okay, so in the next slide, I just want to acknowledge our partners on this project, from local volunteers to our funding organizations, in particular the Department of Ecology's Section 319 funds, to technical experts from a number of agencies. And of course, this project would not have been possible without the full support and enthusiasm of the Triple Creek landowners, who we share a conservation easement with. And if you're interested in learning any more about this project or different aspects of it, you can check out our website, OkanoganHighlands.org, or videos. These are primarily about our process for Beaver Dam Analogues. Okay, thank you.